Good afternoon, all the audience. I know some of you are already online. Today, we are very happy to have our partner, Mender IO. They work with us to enable a platform for the IoT. We all know for the IoT, the challenge is not only the connection, the management platform is also about the security. Then today, Drew from Mender IO will share with us what they are doing and what they do together with us. Okay, Drew, it's your turn now.
Great. Thank you so much for the introduction. And want to start by thanking everybody for attending today. I know your time is valuable. Took a brief peek at the attendee list, and I recognized a name or two on there. So thank you all for attending. Hopefully you guys will all get something out of this. Wanted to start with a little bit of background. Who we are is Northern.tech. That's the corporate entity behind the Mender project. We are a team with quite a bit of experience managing Linux devices at scale. You see some of the logos on this slide just to kind of give you a feel for who our company is. We are a geographically distributed team. We have offices in San Francisco and Oslo, and then we have a number of home-based employees such as myself. I'm actually in St. Petersburg, Florida. So we are quite distributed. We get folks in a lot of different time zones. So you know, we've got lots of help online when you do need support. The mission of our company is securing the world's connected devices, and we take that very seriously. We'll go into some details here in a bit, but obviously there's quite a bit of activity in the IoT space, and there are quite a few security issues that make the news headlines, and I'm sure we've all seen them. Our product Mender is one of the first steps necessary for securing these devices. And you know, the idea is that if you can't install new software on the device, you can't respond to issues. And as we all know, anytime you issue any kind of software device, there will be issues that require updates. And so our collaboration with the UP Squared platform is driven primarily by the speed and performance of this of the UP Squared board based on the Intel Apollo Lake. This is a very high-powered embedded board. We've had a number of users on our community Mender Hub site request access for this board to have a Mender integration on it and are using it in their designs. It does have a very mature BSP based on Yocto and the Meta Intel layers in the open source community. It's a very popular board, and like I said, it's an extremely powerful board, especially when you're compared with the other kinds of devices that are available out there. We do have a reference integration using the Yocto project on the Sumo branch, I believe it is. This reference integration is a complete environment that will allow you to build an image with Mender fully integrated, on which you can do OTA updates running on the UP Squared board. If you already have a custom Yocto system, maybe running on the UP Squared board, or maybe looking to migrate to the UP Squared board, our Yocto integration layers are publicly available and very easy to integrate into your custom build as well. So you can either start from scratch or start from a custom build that you may already have. Additionally, we are part of the UP Squared software IoT frameworks as to provide OTA updates, and you know, we are available as standard open source and through the IoT frameworks provided by the UP Squared team. So let's talk a little bit about what makes software update challenging. A lot of the customers and users we've spoken with, especially early on, they were considering rolling their own system. You know, most developers look at it and go, "Oh, I can cobble together a script to update a system, no problem." But they tend to vastly underestimate the complexity and cost of this system. even the typical roll your own system usually takes 6 to 12 months to get something working robustly and with industry standard security practices. Mender itself is several years old, and we're continually adding new features to it. So it can obviously be significantly longer than 6 to 12 months, depending on exactly what the feature set you're looking for. The other issue with a roll your own type of situation is that generally speaking, if you are a device developer of some kind, your competency does not lie in the software update mechanism. So it tends to be given short shrift, and maybe you won't be able to address all of the features that really you should have in your solution, putting your device fleet at risk. And quite simply, it just adds complexity to the product lifecycle and puts your schedules at risk. I can't tell you the number of users that have come to us with a design. They're ready to go to market. They're planning on going live with their product within 2 to 3 weeks, and they want to add OTA capability in at the very last minute. There are a lot of decisions that need to be made, and the OTA mechanism needs to be considered as part of the design from the very beginning, built in and tested fully as part of your overall system design. The focus for Mender, our primary, our prime directive, as it were, are security and robustness. We do have a white paper on that details a long list of requirements that should be considered when implementing an OTA capability in a system. Obviously, security is extremely important. Things like TLS communications, proper certificate management, key pairs, things like that. Those are generally speaking well understood, well solved problems, but they require expertise to make sure that you are following industry best practices. Robustness, when we use that term, what we mean is that there is very little chance of leaving a device bricked in the field. The more robust the system is, the less cost you have in terms of sending technicians on site to repair broken devices and that kind of thing. Beyond that, a user-friendly web user interface is a good feature to have in terms of being able to manage large device fleets, server management, scaling. As the size of your device fleet grows, you want to make sure that your server management backend capability is able to scale appropriately with it as well. And then from our perspective, we wanted Mender to be an open source project, and we wanted a vibrant community to be able to contribute things and to be able to contribute new integrations, new features, product ideas, things like that. As with the UP Squared board that we'll demo here in a minute, that's all managed through our community site, and we get lots of interesting contributions from community members. Now, I suspect most of the people on this webinar probably understand why the over-the-air updates are becoming more of an issue. But let's just talk about this for a second. We've all seen the headlines about things like the botnets that are out there. A couple of years ago, there was a major outage at one of the primary DNS providers that took down some pretty big names. And that was caused actually by a botnet composed of insecure Linux IoT devices. Most of them were, consumer-grade routers and webcams and things like that. They were able to be targeted simply by using the default credentials that are documented in the device instructions, and the end users put the devices on the internet without changing the username and password. So these botnets, the early botnets simply used credentials and were able they were able to do quite a bit of damage that way. Some of the more recent malware is getting more sophisticated and doesn't necessarily rely on credentials, but is able to take over devices based on software vulnerabilities and that kind of thing. So I think the risk to your reputation and your bottom line is great. If you're trying to release a device, we all know that the profit margins, especially on the consumer level devices, are pretty low. So it's definitely something that you need to consider moving forward. You want to avoid costly recalls and things like that. Just a little bit more detail, a couple headlines you see on this slide. Most of these devices are running Linux, a Linux variant of some kind, and the number of attacks and potential attacks on these devices is going up. This does add to your costs as the developer. You need to, if you have devices in the field that are attacked, you need to spend time and resources mitigating those attacks. You also have to spend time in your development cycles to make sure your devices are as hardened as they can be against the attacks to begin with. And robustness is listed as one of our primary features for a very good reason. Many of these consumer devices, if they are in the middle of an update and the power chooses a very inopportune time to flicker on and off, you may end up with a device that's no longer able to function. A couple of years ago, there was an issue with a smart lock that was recommended by Airbnb, and there was a software update that was delivered to the devices, and the locks no longer functioned, leaving guests unable to access the rentals. This was actually a pretty simple issue that a pretty simple case of a binary for a different device was installed. I believe it was an ARM-v5 versus an ARM-v6 or something like that. And the options to fix it required either somebody coming on site or returning the device and getting it serviced by a technician. Obviously, the amount of downtime in that scenario could be very costly for the end user, depending on what their mitigations were for allowing their guests to get back into the rentals. Mender in particular would have protected against this particular fault because we do have a device type check that makes sure that the image you are installing is indeed specified as for the device that it's being installed on. Additionally, we do have automatic rollback, so even if you do install an update that causes issues with the device can simply reboot and move and roll back to the previously known good configuration. And finally, you as the system designer can install custom post-install checks for verifying things that are unique to your specific application use case. Things such as database checking, maybe. Perhaps you have some peripherals you want to verify the functionality of, that kind of thing. And the Mender state scripting interface makes it very easy for you to plug in those post-install checks. And finally, the Mender server, the Mender client also does a verification after reboot to make sure that it is able to reach out and communicate with the server. If for any reason we're unable to reach the server, that's considered a failed update and we will roll back. The reason being, we want to make sure that anytime we install an update, we can always connect to the server to be able to install yet another update to repair any issues with the current system that was just installed. Also, top on our list, security. This is fairly self-evident that security is required. Tesla had an issue back in 2016 where they were some security researchers were able to actually install unverified firmware on the in-vehicle infotainment system in some of the Tesla vehicles, and this was caused by lack of cryptographic validation. Such that a man-in-the-middle attack could successfully deliver an unverified binary, and there was no check on the target system to make sure that the binary being installed was exactly the one that should have been installed. This is a feature that is supported in Mender. The verification key is deployed onto the target device, and even if something were to happen and a man-in-the-middle attack was attempted, unless they also had access to your signing key. They would not be able to deliver an image that the Mender client running on the device would even try to install. And in terms of systems that don't have an over-the-air update capability, this is really puts you at a disadvantage in the market. Back in 2015, there was a number of headlines about some Jeep Cherokees that were able to be taken over remotely. There was a set of steps where over the LTE connections that were built into the vehicles, attackers were able to actually take over the devices. They were able to bridge over the CAN bus and control the automotive components of the system, such as steering, brakes, and that kind of thing. Obviously, this is a huge issue. Unfortunately, for them, they did not have over-the-air update capabilities, so the options were limited to returning the vehicle to a service center and having the technicians install the update, or having a USB stick mailed to you as the owner of the vehicle. Obviously, either solution is costly both to the vendor as well as to the owner of the vehicle. And so having the over-the-air update capability certainly would have minimized this cost to them. And alternatively, having an over-the-air update capability does give you some distinct advantages. Tesla, they do have an over-the-air update capability. It avoids the issue of manual recalls or having to send out USB keys and having to rely on users to properly install the updates. That reduces their costs. It also allows them to generate additional revenue. They can add new features without you, as the owner of the vehicle, bringing it back in. I think they had a ridiculous mode or something like that they were able to enable. If it had a certain cost if you bought it, if you included it when you bought the vehicle, and if you decided after the fact you wanted to add it, you could add it in, and that would generate additional revenue. Also, just one interesting point: a couple years ago here in Florida, Hurricane Irma came through. And Tesla was actually able to reach out to Tesla user vehicles and increase the automobile range over the air during the evacuation from Hurricane Irma. So that one kind of hit home for me, since I was waiting in the lines of traffic trying to get out of the way of that hurricane. So that's a very useful feature. And just briefly, a few more things. Health and safety issues. I mentioned the Jeep Cherokee hack. Obviously, that can be a bad thing. Pacemakers. There's a lot of medical devices being developed with internet connectivity built in, and the potential issues with those kinds of devices. They can definitely be catastrophic. So we definitely want the ability to keep those devices secure and be able to react to issues as they come up. All right, so let's dig in a little bit here, more on the technical side. So this slide shows a number of the components and steps in the update manager workflow. The items that are listed as environment specific technically are not a must-have, but some of them I would say at this point pretty much should be considered mandatory. So starting with at the upper left, that's the initial detection of an update. So you have a client running on a target device, and somehow that client needs to be notified of an update. When you're working with an end-to-end system that has the management infrastructure similar to what Mender has, that goes over a secure TLS channel to the server, and there's a polling interval at which the client reaches out to the server to detect the update. From there, ideally you do a compatibility check to make sure that the image you're downloading is the right image for the particular hardware on which you're running. You certainly don't want to be running the wrong image. Obviously, the next must-have component is some means to download. the update over a secure channel. Ideally, TLS is perfect for this if you have the bandwidth. Moving on from there, integrity checking. This is really intended to protect against faulty downloads and that kind of thing. Then the next step, authentication with the key pairs and the signature verification. This is an additional step that protects against malicious hackers. So if you have the checksum verification, if you have the signature verification, sometimes you can get away with not doing the checksum verification, but it's simple enough that generally speaking, you're going to want to do both steps. From there, you may want to decrypt if you separately encrypt the payload. Since you're using a TLS channel which is already encrypted, you may not have encryption built into the payload, so that may be optional. Extracting and then pre-install actions is pretty important. So this is where you can do checks to make sure, additional checks to make sure that this is the right image for your system or other things that are specific to your particular use case. From there, obviously, we move into the install phase. That's pretty standard, pretty expected. And then post-install actions, again, that's pretty important to be able to customize the OTA update workflow to your particular environment. And then from there, sometimes you're going to have to restart depending on the update type. Obviously, if you're installing a new kernel and things like that, then you need to restart for that kernel to be active. And after the restart, then you want to do your post-install sanity checks and any failure recovery, including rollback to previous known good configurations. So going into a little bit of detail now about the specifics of Mender. As I mentioned, Mender is fully open source. All our code is available on GitHub. It's all written in Golang. We have a few options for hosting the Mender server. You can use the open source version. We have pre-built binary containers available in the Docker Hub, as well as Docker Compose files to help you get that set up and running. We do have our hosted Mender, where it's just a software as a service. You just subscribe to our hosted Mender. You get a tenant token that goes into your device, and you can keep your focus on the embedded side. We also have our Mender Enterprise, which is a more feature-rich on-premise installation for larger device fleets where something like a hosted instance may not be viable given security consideration. Additionally, we have a professional services team, and this is where I spend the majority of my time, helping users to actually implement Mender in their device fleets, customize it for their particular use cases, integrate to new boards, and things like that. We do have, looking at the diagram on the right, you see that we have an active and a passive partition. Our primary means of handling robustness is the redundant root file system approach, or the AB partitioning. This allows us to have fully redundant root file systems and rollback capability. So that's our primary update mechanism, is that full root file system update. Additionally, we have support for different kinds of updates, such as application-based updates, just delivering packages such as APT packages or IPK packages or RPM packages, containers. If you want to deliver container-based updates over the Mender workflow, you can do that. Things like if you just want to deliver a few files and don't want to mess with full packaging or anything like that, that can be done as well. And then with a little bit of custom coding, we can also support updating bootloaders in the field, as well as proxy deployments, which is kind of interesting when you have multi-processor systems where you have maybe a Linux system running on a couple of cores, and then maybe you have a small RTOS running on a sequestered core. And so in those circumstances, you can continue to use the Mender workflow and essentially you're proxying updates to your say your RTOS image or whatever through the Mender client. If you are using the full image updates, those are guaranteed to be atomic. No component outside of the OTA update system is aware of any update process going on until the process is complete. So if there is an interrupted update for whatever reason, nothing else in your system even needs to know that it happened. It all happens in the background. Your application keeps running, and until such time as the update completes successfully, there's no need to reboot or anything. And with the update module functionality that we just rolled out, you can install and update anything on your device. If you just want to update your particular application but leave the kernel and everything else in place, you can do that. And I mentioned the security previously. We're using standard TLS for encrypting the transport between the client and the server. As well as the key pair code signing to ensure to protect against man-in-the-middle attacks. And just a couple other things to mention here. Obviously, compression is pretty important to save bandwidth. These systems tend to be fairly large, but fortunately, in a lot of cases, they compress pretty well. So that makes quite a big difference there. Integration into Yocto is very easy. We have a meta layer that you can just add to your existing Yocto configuration, set a couple configuration variables in your local.conf, and rerun your build, and now you have a fully integrated Mender environment. We support SD, MMC, eMMC for most of the boards, or raw flash on boards where that's an option. Pretty much any block-based device. So if you have a system that uses mSATA or just a regular SATA drive, that can be supported as well. I mentioned the scripting interface to adapt to your particular use case. One other possibility, if the scripting interface we have doesn't give you quite enough enough control of the OTA workflow, our server is all microservices, and each of the microservices has a public API. So if there are things that are not available out of the box for you, it's very easy to, with some custom Python scripting or whatever languages you prefer, to be able to go in and actually trigger deployments, create device groups, whatever functionality you might need to add, that can all be handled over the backend API. And finally, I mentioned it briefly, but it is very low system overhead. Mender's requirements at runtime are modest. We don't require a whole lot of libraries and things like that. The Mender client is written in Golang, and as long as you have a Yocto build, you can get the Mender client up and running. The Mender client just runs in the background and downloads its updates while leaving your application running. So you are able to have your system live, and it minimizes downtime and impact to the end users of your devices. And I mentioned previously that it's fully open source. Everything is available on our GitHub site, and instructions to get it up and running on your own. The community site that I mentioned, Mender Hub, that's one of the best places to start to kind of get an idea for how people are using it. If you're having an issue with it, you have a specific use case, I would definitely recommend starting at the Mender Hub. The chances are pretty good that somebody has had a similar issue, and you might find the exact solution you need. The web UI is very intuitive, very easy to use. Integrating into your build, that's been mentioned previously, that's pretty straightforward. We do have approximately 80% test coverage, and we're very diligent about keeping that test coverage up. As we add new functionality and features, we generally do not allow changes to come in that reduce the test coverage. So we've got pretty good coverage there. And everything you need to get started with Mender is available. We have tools documentation. We've had a lot of very positive comments about our documentation. And then we have our professional technical support team, as well as our professional services teams that can help get you up and running pretty quickly. And with that, I'm going to move into the demo. Let's start with the Mender dashboard. This is the primary interface to Mender where you can view your fleet at a glance. You can see summary information about your devices as well as about any ongoing deployments. Moving over to the Devices tab, you can see that I have one device in my fleet. It's an Intel Core i7-64 device running the Release 1 node radio code. My setup here is an UP Squared board with an LCD panel attached over HDMI. I'm running automotive grade Linux. Note the icon count on this front screen. Note specifically that there is no radio icon. Let's take another look at the device details in the Mender web user interface. From here you can see things such as the device identity, which out of the box is composed of the MAC address, as well as the device inventory, which is a set of key value pairs. Both sets of information can be updated by you based on the needs of your particular device. On the Releases tab, you can see information about all the versions of software that are available to install on your devices. In this case, we have two versions, one with and one without the radio. Opening up the release details, you can see what kind of image, what kind of artifact that you have. In this case, it's a full root file system image update. Drilling down a bit more, you can see some details such as the original file name, the checksum, file size, and other similar generic information. Now let's take a look at the Deployments tab. This is where all over-the-air updates are triggered to your device fleet. Once you create a deployment, you need to select a target release. In this case, we'll select the one with the radio image, and then you select a group of devices to issue the deployment to. In this case, since we only have one device, I'll simply select all devices. Take note of the device type listed here. In the case where you have multiple device types in your fleet, there is a type check done to ensure that you are installing the proper image on the devices to avoid corruption. Now just click Create the Deployment to start the update process. Once the deployment has started, we can check the status. We see here that it is in progress. If we click on the deployment in the list, we can see more details. This tells us that the device is already downloading the image. Now, in this particular case, I'm actually going to simulate a failed deployment by pulling the power as soon as it starts to reboot. This should demonstrate the rollback capability of Mender. While this update installs, let's jump over to the Mender documentation site. In our Getting Started section, there are instructions if you want to download and set up this environment on your local system. We provide a Docker Compose file with all the details and components needed to actually run a Mender Demo server on any system that is capable of running Docker containers. Out of the box, this environment will include an emulated device. There are images that you can download and deploy to this device to start getting a feel for the Mender workflow. To build a Yocto image for the UP Squared board containing Mender, go to our Mender Hub site. This is our community site for device integrations. This page you're seeing here will walk you through setting up a full Yocto build environment on the Sumo branch. All the instructions here will get your build up and running and walk you through the initial provisioning of the device with the produced images. If you want to replicate the automotive grade Linux setup, there is also a discussion page on the Mender Hub site that will walk you through this. These instructions are very similar to the previous ones, except that there are a few additional repositories that are needed to be included in your build. Now we see our board has started the reboot after the installation is completed. Once it comes up, gets through the bootloader, and starts running the kernel, I'll pull the power to simulate a failed update. Now the Mender logic in the bootloader detected the failed update and has successfully rolled it back to the previous known good configuration. When this system finishes booting up, we'll see the display without the radio icon in the list. Back over in the Deployment Process tab, we see that the deployment has completed with a failure. You can download and view the logs from this screen. In this case, it won't tell us much since it was simply an external power cycling issue. Now we'll go ahead and recreate the same deployment that we just tried. This time we'll let it run to completion so that we can see the addition of the new feature into the target image. The deployment is created in the pending state. On the next check-in on the polling interval from the client, the client will start the download and we'll see the deployment move from the pending to the in-progress state. After the OTA install is completed, the device reboots, and now we see it coming back up again. And as expected, we now have 9 icons on the home screen, including the newly added radio icon. Okay, so that's all the details or all the content that I have on this last slide. There's a number of links. Most of these, the first 3 are the same links that were shown in the Mender demo. Then there's the Up community links to help kind of get you up and started and running with Yocto and Mender on an Up Squared board. Lots of contact information here for both entities. So feel free to reach out if you have any questions, and we'd love to hear from you. And with that, I think we have time for some questions.
So if you have any question, then there's a question box, so you can fill in your question. So Drew, maybe you can also explain us if our user follow everything on GitHub, then build a Yocto, have a Mender integrated. So if they are happy with their prototype, then what's the next? They subscribe directly for the professional service, or what should they do?
Yeah, so there's a couple options there, and really it's going to depend on the expertise that the team in question has. As mentioned, we do have our professional services team. So if you want our help actually doing the integration, or if you are new to Yocto and you need basic Yocto consulting, we can do that. On the server side, we can also help if you're looking to roll out your own server, but you have questions about scaling, cloud providers and that kind of thing. We can help with that. Or if you have all the expertise and just want to use our hosted service, that's an option as well. And if you have a need for our Mender Enterprise with the extra features and support that comes with that, feel free to reach out. We'd love to talk to you about that.
Okay, Drew, we got a question from chat box. Yeah, so if you can read that from the chat box. Do you provide any integration support for tools such as Jenkins, CI, or JFox? I'm not so familiar with that.
Yes, so I mean, the basic integration with things like Jenkins is through our Mender backend API. So you can easily trigger new deployments. You know, if you have, say, a Jenkins nightly build set up, you can have one of the nightly builds set up, or one of the steps in your nightly build set up for to upload the new artifact and automatically create a deployment to your testing devices. When it comes time for production releases, you can do similar things. So as far as integration with your build systems, everything is available. You know, all the functionality in the Mender backend is available over the API, so you can plug it in at that level to do whatever you need. As far as JFrog, we are working with JFrog. I don't think we have anything specific today, but that is something that we're looking forward to. So you know, I would say just keep an eye on our blog site. That's where anything specific we do there will be announced.
Okay, cool. Drew, we have another question from Q&A. Since we mentioned a lot about the Yocto, then there's an audience asking, can he run Mender with UP Squared in Ubuntu or any other operating system?
Yes, we have a utility called Mender Convert, which is intended to be used on things like Ubuntu and Debian that are distributed as, you know, pre-built binary images. Essentially, it's a post-processing tool that's able to function. It takes as input a block disk image, and it will inject the Mender client configuration files and generate the multiple partition images that are needed. Out of the box, we support Debian on BeagleBone Black and Raspbian on the Raspberry Pi. For just about every combination of board and OS, it requires a little bit of customization. So if that's something you're interested in, feel free to drop me a note with the details, and you know, we can discuss doing that through our services team if that's something that would be of interest.